so now we're just getting into the fun stuff. This stuff is less educational, but it's way more inspirational. I want to throw some of the projects I've worked on and some of the little modules you can play around with at you, so you can kind of get a feel for what you might want to look at more on your own. I'm not going to go into too much detail. A lot of this stuff is Googleable, and there's a lot of explaining behind it. And for the most part, I think this is more to just show what's possible, right? So here's something I did. I was watching my friend's lizard. This is Tracy the lizard. Tracy would usually hang out under rock 1 because there's a heat lamp that keeps it nice and hot, but occasionally Tracy would get too hot and go hang out under rock 2, and then when she got too cool, she'd come back to rock 1. So I wouldn't see her a whole lot, and I thought, man, I have this lizard that I'm watching from my friend, and I really don't ever see it. I wish I could see it more often. So I used that same distance sensor I just did the project with, hooked it up to a Raspberry Pi, which is very similar to Arduino. It's a little bit smarter. It has Wi-Fi capability, which was helpful. That was plugged into the wall with a wall adapter, not directly connected, like think about a phone charger. And then it's got a little camera here on the inside of the tank. So what I ended up doing, as you can see from the setup, is I set up the distance sensor to judge the distance from there to the ground, and when the lizard will walk by, the distance would change. And then the Raspberry Pi would text a link to my phone that I could then open, and it would be a live stream of the inside of the tank. So you can see in this, Tracy was moving here. Forgot to screenshot it because I was so excited that it was working, but I saw Tracy go through the entire length of the tank here, and you can see under the hot rock right now, having a good time. So there's a bunch of random modules and other stuff that I could teach you. It's kind of fun to just explore on your own, and obviously there's so many that I can never really get into them. There's a ton of good guides that are already written about all these things. The more that you know about something, the more control you have, and it lets you think of a larger variety of ways to use it. You can be a lot more creative. So if you have a module already, it's fun to just kind of research a little bit more and see if there's other uses you can do for it, or if you normally use a library to operate a device, trying to do it manually without the library, and then you really understand what's going on in the background. There's thousands of modules out there. They have slight differences from what I or other resources use. They're manufactured differently. Certain settings might be different, especially with the Arduinos. There's a lot of knockoffs, and they require a lot of small changes in your IDE settings that, again, too exhaustive of a list to completely get into, but as long as you keep Googling, I promise you, you can figure it out. It's usually not that complicated. Trying to get a project first and then find the modules and build everything after, it doesn't always work, and then you've already invested a bunch of money into it. I would suggest normally just working with stuff you already have and introducing new modules one at a time so you get a good handle on it without biting off more than you can chew. I really want to just expose you to some of these things because I didn't really understand them until I was in college, and I kind of researched a lot on my own. And Google is definitely your friend because they have a ton of resources that will explain better than I can. So first one is a button. You can see the circuit's pretty simple. You can buy a ton of different buttons. This is how the inside of it works. The top two little legs here and the bottom two legs are connected electrically. When you push down the button, it just closes the circuit. So for this, you have this pin is reading. You have power going to the button. When you close it, the power goes into the input pin, and it knows that the button is being pressed. You have something called a pull-up resistor here. That's just to help the signal be more consistently 1 or 0. There's something called a hanging input, which it kind of flips back and forth. I'll let you Google that if you want to learn more about it. But again, if you just want to use a button, you can just copy the circuit, understand it later. Here's the code. You're just setting up a constant integer. It's pretty par for the course if you programmed before. You have a button pin, which here is 7. I don't think this one's actually wired to 7. This one's wired to 2. But you just set it as an input, and then you just read the state of the pin, and it's going to be high or it's going to be low. And then you can, in this one it just prints out low or high. Not complicated. But then obviously you have this variable current state that can change, and then there's a lot more programming stuff you can do with that. Switch, the exact same thing as a button. Just think about electrically. Depends on, again, the switch you get, but for this one, I'm pretty sure this one pin right now, because the switch is to the left, So this pin is going to this pin on the left, and then if you switch to the right, the middle will go to the one on the right. So you can use that to kind of make a circuit. Maybe, you have power here and ground on this leg. So when the switch is to the left, it closes the circuit. But then when you switch it to the right, the power goes to just nothing, and there's no circuit. The other one is a capacitive touch sensor. How it works is a little bit complicated, but usually with a library, it's pretty easy. It can sense your finger touching it, which is pretty cool. It's not just pressure, it's like actually your finger. It's the same thing as your phone screen. If you hit it with a pencil or something, it won't work, but it knows when your finger's there. That obviously also works very similarly to a button. Radio transmitter. This is awesome. This one is, the shipping is $4, but the device itself is under $1, which is crazy. You could buy 10 of these and it would probably come out to $15, which is just awesome in my opinion. And then you have this huge specification here of all this information about it. I don't know what 90% of it means. I don't need to know what 90% of it means. I'm going to take the name of this module, I'm going to type it into Google, and I'm going to see what comes up, and usually I'm going to be able to make it work. And it's a radio transmitter. What does a radio transmitter do? It's probably going to be something similar to a walkie-talkie. If I have multiple Arduinos, it might let them interface with each other, which is really cool, right? And maybe I'll read through this stuff and just kind of read and pick out the stuff that I do understand. Oh, the size, 34 by 17 by 1 millimeter. All right, I know what that means, right? So you can pick out parts from the spec that you want if you're specific about maybe a size or a certain power supply that you need to give it. But for the most part, this is a really simple, really cheap radio transmitter, which is something that could be awesome if worked into a project properly. And you really don't need to know that much. It's going to give you a lot of information, but if you just go to Google, it'll usually give you the nuts and bolts, and you can expand your knowledge from there. Other power options. So usually we just have a cable, or you saw earlier, you had a battery. Here's another example. You just put 4 AA batteries in, plug it in. 9-volt battery, pretty standard. So the 5-volt, this is usually going to be an output of 5 volts from the Arduino. This is a Arduino Nano. It works exactly the same except for the board's smaller. But if you're giving it power, you usually want to go in the voltage in, because that way it can take voltage higher than 5 volts without damaging the board. So pretty much anything that can supply that power, you can put into here. Obviously there's a limit. Pretty sure it's 12 volts. Anything more than that will still damage the board. But it lets you kind of play around with other ways to power the device. Output, so having a logic show in the real world, the easiest way to do that is an LED. Very simple, but also with LEDs, you're almost always going to need a resistor. So you can see power goes into the resistor, into the one leg of the LED, and then into ground. So this one is just always on, or no, it's not. It's red, which is confusing. That's another thing. Be careful with your wire colors. Red is usually going to be power, black is going to be ground. So these 9 and 10 are 2 different pins that are probably going to be output pins. And if it's outputting, it's going through the resistor, going to ground. This one also, as you can see, goes to ground because this whole rail is all ground. And both of these will light up separately. Connecting LEDs, you got to also be careful about this, because depending if you do it in series or in parallel, it can have a different effect. Here you see this battery is 6 volts, this one's 12. This one only needs 1 resistor, this one needs 4. If you get these numbers wrong and you give the LEDs too much power, it'll burst and it'll break. It's not going to cause any harm to anyone, but it just makes the LED useless. Motor, super easy. Red goes to power, black goes to ground. You can have an input-output pin that you just turn on and off, and it turns the motor on and off. It also has something called reversing the polarity. So normally you look at an Arduino, it has a place where you want to put current in and a ground where it wants to kind of take it out. You have your positive and negative terminal of the battery. But for a motor, even though you have a red and black pin wire, you can give it current going either direction, right? So this black can actually go to the positive side of the battery or into your 5 volts, and the red can go to ground, and it just makes the motor spin the other way. So if you get into more complicated circuits, you can get one single motor that can, move one way and then move back the other. But we're not going to get into that for now. Peltier module, these things are really cool. It can turn electricity into, on one side it gets extremely cold, on one side it gets very hot. So as you can see here, these Peltier modules, This is frost because it's so cold, and then it's putting a ton of heat in this little box here, which is, I'm guessing, going through these pipes to something else. So same thing as the motor. You just plug one side into power, one side into ground, and one face will get hot, one face will be cold. With Peltier, I think they're a little bit more particular about reversing the polarity. Again, just look at the guide when you're buying it and when you're making your project. But it can be pretty cool for heating up. Maybe can heat some water, can keep a small little box cold, right? You can have a mini refrigerator. Plenty of applications for this. LCD displays, these are also really cool. Again, usually going to use a library for it, but it's a really simple way. You can just display text. You can make a little image. This one's got different colors. It's very cool. Soldering. So soldering, I mean, it's not a device or anything, but it's the nature of using what is called a soldering iron, which is just a hot iron with electricity going through it. And this, you can use a lot of different things here, but it's usually going to be something like tin. But essentially, you're making electrical connections. This is more of a hobby, but it's still kind of fun when working on your projects. If you want to permanently assemble certain things, you don't need this skill, but for those that are interested, I'd also look into soldering if you're really getting into some of these projects. So this is a testing board that goes on top of a regular Arduino that you can connect things to and solder them all together, make your own circuits, and then test it before, kind of as a prototype before you make a real version. I don't think you're going to be using this unless you get really into this design, but it's helpful for that. Here's another project I made. This was something that I didn't get from YouTube, but YouTube is obviously a great inspiration for this sort of stuff. But thrift stores, neighbors with old electronics definitely have helped me out in a lot of my projects. So I took an old iHome, which you might not be familiar with, but it's like an alarm clock that charges your phone, plays the radio, it can be a speaker, that sort of thing. I found one in a Goodwill for very cheap. I found this box for very cheap. So I ended up taking apart the iHome, taking apart the parts of it that made it work, rewired it all, and then wired it to an Arduino. There's an Arduino on the other side of this. And so this box now has this other functionality. There's an LED light on the inside that lights up. And then when you play music, this little disc, it's like a record, starts to spin, and this needle arm kind of comes out. So it's like a fake record player. There's buttons on top that control the volume. This switch turns it on and off. This light is an indicator of whether it's on or not. And then this back part here is the speaker. So it ends up being a cool little gift that you can give to people. This still works as a phone charger and as a speaker. And I guess it would work as a radio, but I didn't include buttons for stuff like that. So there's a lot of cool stuff out there. I would just watch some YouTube videos. You can get inspired. And then doing those projects rehearses a lot of your CS skills that you already have. It can be a lot of fun, right? You can make cool gifts for people.